Hello friends, welcome to my channel Shake Hands with Programming. Okay, so today will be a theory class only. Okay, so we'll learn about the difference between a C compiler and Java compiler. Okay, as we all know that C is platform dependent. That is, it based on hardware and the OS we use. It differ means suppose if you are having a Windows over here and if you are having Unix over here. So for two different OS we need two different compilers. Okay, so suppose this is our source code, okay, which is sum.c. We save our source code in C with the extension .c. So this is our source code. Now for compiling it, we can use either turbo C dev and code block compiler or GCC compiler based on our OS operating system. Okay, so if you are having Windows on your PC, then you will need turbo C dev or code block to compile this source code. But if you are using the Unix operating system, you will be needing GCC compiler. Okay, now after compiling, that is when turbo C dev or code block will compile your source code will be converted into machine code, which is also called as object code, and this machine code is sold into market. Now as you can see, if I sell this machine code in market, this would not run on Unix operating system. So this is the main drawback of C language, C compiler. Okay, now if we talk about Java compiler, okay, in Java compiler this is platform independent. That is common for all operating system. Doesn't matter which operating system you are having on your PC, the code will be same. Okay, so suppose as we write our program, we save this with the extension .java. Okay, so this is our source code. Now for compiling this source code, we only have a single compiler in Java, that is JDK compiler, not two different compilers like C, which is turbo C dev code block, and GCC. We don't have two compilers here in G, so this is the main benefit of using Java. Okay, so this JDK compiler is common for both OS. Okay, so after JDK compiler compiles our source code and convert it into the byte code. Now when our source code is converted into byte code, our file, the byte code is saved in form of sum.class file. Okay, and this is sale into market. Now as you can see that when I sell this, it is common for both the operating system, Windows and Unix. Okay, so when I sell this code, it will work in both the operating system, that is Windows as well as Unix. Okay, as in Java we have a thing called JVM, that is Java Virtual Machine, which is platform dependent. Okay, so the JVM machine for Windows is different and JVM for Unix is different. Okay, we'll study about JVM in further lectures. Okay, now moving further, just a second. Okay, so now moving further, we will be moving to our next slide. Okay, so we'll now see that what is the bytecode. The bytecode is platform independent, as you have seen earlier. Right here you can see that this bytecode was common for both the operating systems, so that's why the bytecode is the platform independent code. Okay, so this is the platform independent code, and it is highly optimized code. That it is very fast run, but not faster than C. Why it is not faster than C? Because the bytecode in Java is first converted into machine code and then it is run, so that's why its speed is slower, little bit slower than the C. Okay, no hardware and no OS can directly read the bytecode without JVM. Okay, as I told you that JVM is platform dependent, that is we need JVM for different operating system to run our bytecode on the operating system. Okay, this is very important, as JVM converts the bytecode into some language that is understood by that OS. Okay, so for example, just let me change my color pen. Okay, suppose JVM converts the bytecode. Okay, so here I am having my bytecode. Just suppose, so this bytecode is converted into some language that is understood by that OS. Suppose if I am using Windows OS, Windows operating system, then that JVM will convert this bytecode into that language that is understood by Windows. Okay, now if suppose I am using Unix here, so this bytecode will now convert it to a language that is understood by the Unix operating system. Okay, so both languages will be different, as this language will be understood by Windows and this language will be understood by Unix. Okay, now no OS know how to read bytecode, so JVM for that OS is needed. Okay, now as you can see that this bytecode is common here. Okay, so without the help of JVM, as JVM is converting it here, I'll write it. Okay, the JVM is converting bytecode into some understandable language. If we don't use JVM, that is Windows cannot read this bytecode directly without the help of JVM. Neither of the operating system can do this. Okay, so we need JVM for that purpose. Okay, now without JVM, bytecode will not run. Obviously, if Windows will not able to understand, and our operating system will not be able to understood the bytecode, how we will run it. Okay, now what is JVM? JVM is Java Virtual Machine, that is, it is an interpreter. Okay, so before moving on towards the JVM, we will first study about the interpreter. That what is an interpreter? Okay, we all know about compiler, but we haven't studied about interpreter yet. So I'll tell you about the difference between an compiler and an interpreter. Okay, so just a second. Okay, so here we are with the differences between compiler and interpreter. Okay, I'll write it here for you guys to remember it, as it is mostly asked in the interview that what is the difference between compiler and interpreter, and this is a basic question, so you should obviously know this. Okay, so I'll write it in a minute, just a second. Okay, I'll switch it. Okay, so if we see about compiler, this will generate a machine code for the whole program source code and then run line by line. As it generate the machine code for the whole program, it is fast. So no, we do not need to compile it again and again. But in case of interpreter, it generates the machine code line by line and then compile it by line. So for example, it will first translate one line and then run it. Okay, suppose in our program if we are having multiple lines like this. Okay, so it will first translate first line and then run it, then it will translate second line and then run it similarly. Okay, so as it is line by line, it is slow, but Java is not slow, as it has both compiler and interpreter and they both work together. Okay, in case of compiler, suppose if we are having multiple lines like this, it will not compile it line by line, it will do it in a whole. So it will first translate all the lines in a go and then it will run it again in a go. So that's why it is comparatively fast than interpreter. Okay, so now if we talk about JVM. Okay, so just a second. We will be studying about the working of JVM in our next lecture. So that's it for this lecture. Thank you.